So yesterday we talked about arithmetic series. Today it's geometric series. So all this is the sum of a geometric sequence. Okay. The sum of a geometric sequence. And so we have a formula for this one, just like we did for arithmetic. Looks like this. The sum of the n terms that you're interested in is equal to, this is a big old fraction, the first term times 1 minus r to the nth power all over 1 minus r. Let me make sure I muted everybody. There we go. Okay. Then it's where n is the number of terms, just like it has been. Where a1 is the first term, and r is the common ratio. So for arithmetic, we had to have the first term and the last term. We don't have to have the last term here. We just have to know how many, and it will all kind of take care of itself. So let's see how this works. It says to find the indicated sum. So we know we have to have the first term. In this case, the first term is clearly 2. We have to have n. Well, n is 9. And we have to have r. R is your common ratio. Well, when I look at the sequence part of this, that I'm just multiplying by 5 each time, so r is 5. So then I'm just going to put it into that formula up there. The sum of the first 9 terms is going to be 2 times 1 minus 5 to the 9th power all over 1 minus 5. Keep in mind that in the numerator, I cannot make what's in parentheses into negative 4 to the 9th power. That doesn't make any sense. Okay, so you just type it all in the calculator just like you see it. So if I do that, I'll have a fraction. I'll put 2 times 1 minus 5 to the 9th power. Close my parentheses. In the denominator, I get 1 minus 5. And that's my answer, 976,562. 976,562. Okay, any questions at all? All right, so you go ahead and try number 2. So before you put in the calculator, double check that you have it set up like I do. And keep in mind of your whole order of operations, even though this is 1 minus a negative 1/2 to the 8th, I do not get to make this a positive because it's the negative 1/2 that gets taken to the 8th power. So, okay, thank you. So make sure that you're using your parentheses correctly and your negatives and all the good kind of stuff. So for sure, type this one into the calculator because I don't want you missing things because of the way you're typing it in. because that would probably be the most common reason for a mistake on these. So I'd have a fraction, let's see then, 72 times 1 minus, then negative 1/2, close those parentheses, take that to the 8th power, then in the denominator 1 minus negative 1/2. This is what my calculator gives me, but I don't want a decimal, so I'll use my little fraction button. I'll give you a second to get it typed in. Make sure you can get the right thing. What you should have in the end is 765 over 16. Any questions about that? We're all good? What, look at the calculator? Yeah. Lots of parentheses there, and it's really safer just to go ahead and let the calculator do what it's going to do instead of you trying to simplify any of it. Okay, we good? All right. So let's look at number 3. So number 3, same idea, but I have, it's in, ooh, I almost gave it away. It's in this notation. What is this symbol called? Sigma. Okay, good. So it is in sigma notation. But I still need the same things. And I know, and I can tell by looking at this that I get to use this formula because that is a geometric sequence formula. So I'll be able to use my geometric series equation. I'm going to need n. I'll go from 1 to 7, so n is 7. The first term, when you have a geometric sequence, is right there. So first term is 3. Then this right here is your r. And those are the 3 pieces that we need. So go ahead and set up your little equation here. That's what it should look like. And then go ahead and type it in if you haven't already. You should get 9,831. Any questions at all? Okay. All right, we are not going to do number 4, so you can go ahead and go to the next section. And we're only going to do really part of number 5. The only thing I want to do in number 5 is come up with the pieces. We're not going to worry about putting it in there. So the first thing I need n. What would n be in number 5? Because since we don't start with 1, it's not 13, right? To find that, you take the smallest number and add 1 back. So it would be 12, right? All right, so the first term is actually not a sub 1. The first term is a sub 2. Now, because that's what we're going to need to use. That's the actual first term in the sum that we want. Knowing A1 could be helpful. A1 is 7, but that's not what I'm using. I'm going to have to use this one. But I'm also going to need R, and since R is 3, if the first term is 7, the second term has to be 21. And then this is what I'd be using. Okay? We all good with that? All right, bless you. Okay, so let's move on to number 6. And I want you to try and come up with these 3 things on your own. We need the n. We need, in this case, it would be the 5th term. And we would need r. So if you can come up with those 3 things, and then I'll talk about it. Oh, you wouldn't actually be using this one at all. These are the 3 things that you would use in there. So this would be your first term that you use. Well, let's go ahead and come up with these 3 things together too, just in case. What do we get for n here? 8. Okay, good. Now, the 5th term, we don't want to have to write out 5 terms. I can go ahead and just substitute this and use this. So I can say for the 5th term, I'm going to get 1 over 20 times negative 5 to the 5 minus 1 power. And that would give me the 5th term because I'm basically just using my little rule there. Okay? Just like we were doing when we did these on Tuesday. And then when you type all that in, that 5th term will give you 125 over 4. So that's your 5th term, which is the first term in your series. So that's what you use as A1 in the formula. What is R here? Negative 5. Yes, very good. All right, so then when we do this, we want the sum of these 8 terms. The first term that we're using is 125 over 4. We multiply that by 1 minus our r, which is negative 5, to the 8th power, all over 1 minus negative 5. Okay. And then type that in. So that will give you negative 2,034,500. Any questions at all? All right, let's look at a couple of application problems. So number 7 says the grocery store started raising money for local schools. In their first month, they raised $4,000. Each month after, they raised 1.5% more than the previous month. Find the total money raised in 4 years. Okay, so if we're doing this by the month and we want to know 4 years, then what does n equal? 48. Okay, our first term, we start with $4,000. Right? Then we need R. Okay, so they tell us that we have this 1.5%, which would be 0.015 when we're talking decimals, right? Yes, that's why I said if you had opened it before you got in here, it would be different. So if I have this 0.015, then everybody else has it though, right? Do y'all have this? Okay, I'm just making sure I uploaded it. Make sure I really uploaded it like I thought I did. 0.015, we want to think about what this actually means. So our first term is 4,000, right? If I find 1.5%, or I take 4,000 and I multiply it, so 4,000 times 0.015, that means that's how much more. I got $60 more the next month. So my next month is $4,060. We agree with that? So that point, or that 1.5% is equal to 60, but this is my first term, this is my second term. So R, even though we have a rate of 1.5%, this is not R. Because if this was R, then I'd go from 400 to 60, and that's not what I want. So what would my R be? It'd be 1.015. Does that make sense? Do we all understand why it's 1.015? It's kind of like getting the total plus tax, right? We good on that? Okay, so that's my R. So those are the pieces that I need. I want the sum of the first 48 months. So that's equal to the first term, which is 4,000. And I know they didn't ask me for the second term, but that's why I just want to make sure we understood what was going on here. Times 1 minus your R, which is 1.015, to the 48th power, all over 1 minus 1.015. So then when we type that in, I have a fraction, and I'm going to have 4,000. That is not 4. That's 40,000. 4,000 times 1 minus 1.015 to the 48th power divided by 1 minus 1.015. So that gives me $278,260.88. So $278,260.88. Did I write that down right? Because I don't have it written on my paper. Are those the right numbers? Because I can't see them at the same time. Okay, good. So then to actually, I should probably actually answer the question and say total amount raised in 4 years is $278,260.88. Fraction totally would not make any sense right there because we're talking money, right? Any questions at all? Careful with those percentages and the decimals and whatnot. We all good? Alrighty. So then let's look at Miss Carol here. Carol wants to be a millionaire, don't we all? So if she saves 1 cent on the first day, 2 cents on the next day, 4 cents on the third day, and so on, how many days will it take her to save $1 million? Okay, so N is what we're looking for. We don't know what it is. We want to know how many days it's going to take. The first term is 1 cent, 0.01. The R, what's R? 2, because it's doubling every day, right? And then the other thing I know is that the sum of whatever the n number of days is 1 million. Because we want to know how long is it going to take to get to $1 million. Okay, we agree with all that? All right. So if I have, let's set up our little equation here. The sum, which is 1 million, is equal to the first term, which is 0.01, times 1 minus R, which is 2 to the nth power, because we don't know what n is, all over 1 minus 2. Everybody okay with where everything came from? All right, so I know down here 1 minus 2 is a negative 1. I'm trying to get n by itself, so I'd like the negative to not be over here. So I'm going to go ahead, and since this is going to give me a negative 1, I'm going to multiply both sides by a negative 1. So this will give me negative 1 million equals 0.01 times 1 minus 2 to the n power. All right, still our goal is to get n by itself. So now I'd like to divide both sides by 0.01. When you divide by something less than 1, your number gets bigger. So we're going to move the decimal place twice to make it bigger. And that will give me negative 100 million equals 1 minus 2 to the n power. The next thing I would do algebraically would be to move the 1, right? So I'm going to subtract 1 from both sides. So I will get negative 100 million and 1 equals negative 2 to the n power. Still want what has my n in there to be positive, so now I'm going to multiply both sides by a negative 1 again so I can get rid of this negative. And I will get 100 million and 1 equals 2 to the nth power. Okay, so my goal is to get that variable out of the numerator, not out of the numerator, out of the exponent. What have we done mathematically that allows us to move the exponent out? It's the only thing we've done. Is what? Logarithms, yes. Remember when you took the log and you had a power that allows you to bring it out in the front? Remember that? So we're just going to take the log of both sides. Whether it's the natural log, whether it's the common log, it doesn't matter. We'll just use a common log. So I'm going to take the log of both sides. So the log of 100 million and 1 equals, so when I take the log over here, I'm going to go ahead and move my n out to the front because that way I don't have to rewrite it so many times. Thank you. Okay. So when I do that, so I'll get n times the log of 2. All right? So now to get n by itself, I can just divide both sides by the log of 2. So the log of 100 million and 1 divided by the log of 2 is going to equal n. Everybody with me? So now I'm going to go do that in my calculator. So I'm going to have a fraction, and then I'm going to have to hit function, and I'm going to need a log in the numerator and a log in the denominator. So I'm going to go ahead and put both of the logs there just so I don't have to go back and forth on the little function thing. In the numerator, I want the log of 100 million, so that's 100, 000, 000, 001. There we go. In the denominator, it's the log of 2. And my answer is 26.575, blah, blah, blah. Okay, so let's go ahead and write that over here. So n is equal to 26.575, blah, blah, blah. So it takes over 26 days, which means my answer then is 27 days. Does that kind of seem like a ridiculous answer? It does. Totally seems like a ridiculous answer, but it's correct, and that's the way exponentials increase. There's a book called A Grain of Rice or something like that that I'll actually read that to y'all next week because it's a children's book, but it's very interesting because it kind of shows you how it really does happen that quickly, and it's kind of a cool book. So we'll have a little story time next week and we'll read that book, okay? All right. Any questions at all? We all good?
I have a question.
Yes, go ahead.
Why did we add 1 to the 100 million instead of subtracting?
Well, we did subtract it, but this was negative. So when since it was already negative and we subtracted it, it just made it more negative. Does that make sense?
Oh, just kidding. Never mind. Sorry.
Okay. No, it's all good. It's all good. I don't want you to be stuck on little things like that. We all get confused. All right. Anything else? All right. Awesome. then we are done for today, but I do have something I need to tell y'all off video here.